Assalamualaikum. My name is Muhammad bin Abdul Aziz. I want to talk about the project ICS for the task 1. This my group is group 5. The first, Ahmad Qayyum bin Ahmad Johan, and me, Muhammad bin Abdul Aziz, Ismail bin Muhammad Abdul Wahab. The lecturer is Dr. Muhammad Razali. Next, I want to talk about the assignment 1 for the task 1. The first, this is for the question for task 1. For the first classification, use the image data in the following link to train the request model. Link to demonstration and presentation. For the first, I want to talk about the introduction. Convolutional neural network CNN is a type of artificial neural network that is particularly effective for analyzing visual data such as image and video. CNN are designed to automatically learn and extract picture from input data by applying a series of convolutional filters. CNN, unlike traditional machine learning algorithm can extract large-scale picture without manual engineering and sensing efficiency. They have translation invariant properties, identifying patterns from data. Pre-trained CNN architecture like BEJ 16, ResNet 50, Inception V3, and efficient nets show top performance and can be fine-tuned for new tasks. CNN can be applied to various domains. Next, this is for the image classification. Image classification is a crucial task in vision recognition, focusing on understanding and categorizing single object image under specific level. It often refers to as image retrieval, which involves finding similar image in a larger database. For the first, image qualification, assign a label to the entire image. Second, focus on identifying and localizing the main object or region of interest. The next object localization. The first goes beyond classification, identifying and localizing the main object or region of interest. Use bounding box to provide detailed spatial information for specific analysis. The last, object detection. Identify target item within in image, label them, and specify their position. Use a bounding box to indicate the location and label of a particular object. For this image classification, and object detection are essential component of computer vision and image annotation. Image classification assign a label to the entire image, while object localization identify and localize main object or region in interest. Object detection located item within an image and assign label. Recognizing target item the position. Bounding box are commonly used for object detection, combining image classification and object localization. That's all for me.
Assalamualaikum and good day to Dr. Razali. My name is Ahmad Ahmad Johan and my matrix number is CE190012. Okay, so for today I'm gonna do the demonstration for task 1. This is the coding structure for model 1. Okay, so for model 1, The first step will be where we connect our Google Drive, and then inside our Google Drive is where we mount our folder of the given. Okay, so this is the coding structure for model 1, where the first step will be where we mount where we connect our Google Drive, where inside the Google Drive contains the given folder, where it contains the image of the can, the pad, and also the tetra pack. And then next step, where we feed the dataset inventory, where we import our OS. Okay, then next step, where we create the train and validation data directory. Here we import the library first, where we use the TensorFlow library, the Keras, the NumPy, and also Matplot library. Okay, and then you can see the command here, where we have the command here, when we run the command, we will get the, as you can see, the output below, where we get the can train length, the pad train length, and also the tetra pack train length. And then we also get the value of the can, pad, and tetra pack validation length. Okay, the total training image that we get is about 1811, where as for the total validation image is about 609. Next, as you can see, the command here is to ensure that the image that we use here is correct, where it's taken from the file that we mount inside our Google Drive. Okay, as you can see here, I've selected about 10 image for each type of the material. So the output will show the image that it has choose. Okay, so next, where the construction of the model, where the input feature map that we use is about 150 times 150 times 3. It consists of 5 convolution, where as you can see, the number of filter keep increasing, and the max spoon layer that we use for each of the convolution is 2 times 2 window. Okay, so as you can see, after running the 5 convolution, after running all 5 convolution, we need to insert flatten feature map to the dim tensor, so that we can add the fully connected layer in order to create a fully connected layer with reload activation and also 512 hidden units. And then after doing that, we can create the output layer with a single node and a sigma activation, where here you can see that this is the output of the model, where we get the total number of parameter is about 970 and 921, and also the trainable parameter value is also the same, which is 917921, and the value of the non-trainable parameter is 0. Okay, and then the next section where we rescale our image, okay, by 1.00 divided by 255. Okay, so when we run, the output will show that all of the image belong to what type of material, where you can see 3 class consisting of 3 types of material, which is the can, pad, and also the tetra pack. Next, we run then we can start to train our model in 50 epochs, as I have selected 50. Okay, you can see here I have run the code. Okay, so based on the epoch value here, it will plot the data. As you can see here, you can see the training and validation accuracy, where the blue color is for the validation accuracy, while the red color is for the training accuracy. Okay, as you can see here, our training accuracy is about 52.46%, while our valid accuracy is about 4.60%. Okay, and Below here, you can see the training and validation loss result. Value has been plotted. Where you can see the training loss is the one in red color and the valuation loss is the one in blue color. Okay, now I'm going to proceed with the model 2. So for model 2, the upper coding structure is about the same as the previous model since we are using the pre-trained model from the previous model. Okay, as you can see here, for this one, I'm using the DenseNet where at here you can see that we import the DenseNet library here. Okay, and then here after we by using this command we run the model and we get the sequential model output value where you can see here the different types of layer here where the total parameter is about 154.27137 while the trainable parameter value is about 838.9633 and the non-trainable parameter is about 703.7504. And here the same as before where we scale the image. Okay, and then you can see the output mentioned that it has found the same as the previous model where it found where the result showing the amount of image that belong to three class. And then for history, for the epoch we run it at 50. Okay, so um, after finish running the model, after finish running the epoch, we can see that we have get the value of the training and validation accuracy, where we get the train accuracy is about 70.40% and the value accuracy is about 3.94%. And for the training and validation loss, you can see here this is the output that has been plotted. So that's all for model 2. I'm going to pass it to my other teammate. Thank you.
Assalamualaikum. My name is Muhammad Anas bin Abdul Aziz. I want to talk about the assignment 1 for the task 3. Next, this is for the question for task 2. The first must be demonstration, presentation, and the report. For the first uh, problem for the task 2 for the project is helmet and reflective jacket detection for worker safety. The first industrial safety important. The first importance of worker will be for employers and employers. Second, evolution of industry necessitates status risk management. For the third, safety helmet and reflective jacket are crucial for worker safety. That helmet and jacket as defend against hazard. The foster a secure work environment, minimize industry risk. Need for a solution for helmet and reflective jacket. Uh, for the statement, the important of worker will being in the industry landscape is crucial for employees. Safety helmet and reflective jacket are essential for a secure work environment and minimizing risk. A solution involving helmet and reflective jacket detector can improve worker safety and provide reliable detection, ensuring a safe work environment. Next, this is for the methodology. The first, you only look on YOLO is a popular object detection algorithm that is known for its real-time performance. The first step in the process of detecting safety helmet and reflective jacket utilizing YOLO for real-time for real-time safety helmet and reflective jacket. For the statement, YOLO, popular object identification method, has been used to create a detection model for safety helmet and reflective jacket. The real-time single shot method uses a deep neural network to recognize and classify objects in a single pass. Each effectiveness is improved to its single shot methodology, anchor boxes, grid-based detection, and multi-scale texture extraction. That's all for the methodology.
Assalamualaikum and good day. Today I'm excited to share with you an interesting and practical journey into implementing YOLO V7, a state-of-the-art object detection algorithm using Google Colab and Roboflow. Let's dive into the code and understand the process step by step. First thing first, to execute this code, we need to mount Google Drive. This allows us to seamlessly access and store files on Google Drive directly from our Colab environment. We start by mounting the drive using drive mount content drive command. After mounting the drive, we navigate to the specific directory where our project is located using cd command. In this case, it is located in content drive my drive uthm ics underscore task2. Before we proceed with the YOLO V7 setup, we check if a directory named 2024 YOLO test exists. If not, we create it using os.makedirs 2024 YOLO test. And then we navigate to the file that we have created. And now let's bring in the YOLO V7 repository from GitHub. We use the git clone command to clone the repository into our project directory. And then we navigate to the file of YOLO V7. YOLO V7 has a specific dependency listed in the requirement.txt. We install this dependency using pip install r requirement.txt command. Next, we download the pre-trained YOLO V7 Wix using the wget command. So now I will move on to Roboflow GUI. So this is a Roboflow user interface. First thing first, we modify and add the class that we require. So for our project, there's two classes, which is safety helmet and safety vest. Then we save and continue. Next, we upload the file, the images to Roboflow workspace. For example, I upload these images, and then we can annotate the image like this. So then we just annotate that this is a safety helmet. Save and enter, and we go back. So the image has been annotated. Since I've already done the processes, I will not save these changes. Moving on. So this is the data set that I have uploaded and annotated. It consists of 139 images. We just See, this is the images that I have uploaded, same part of it that I have uploaded and annotated. And then we move on to generate the dataset and boost the dataset. So here the source images is 139 images. We split the images into training set, validation set, and testing set. Next is for pre-processing. The setting I use is auto orient, and I resize the image to 640 times 640. And then this is one of the important part, which is augmentation to boost the image to the minimum requirement of this project, which is 300 image. So the setting I use is flip, horizontal, and vertical, and then bounding box shear, and then bounding box blur. So there's three augmentation step, and then I create. So as we can see, the image that is augmented contain almost 309 images. So moving on. So here we can export a data set to, since we are using YOLO V7, we set the format to YOLO V7 PyTorch, and then we continue to see the download code. So this is the code from Roboflow. We just copy this code, and then we move back to Google Colab environment, and we just copy the previous code and paste it to Google Colab. So this to simplify the data management, use for Roboflow. We install the Roboflow library using the pip install Roboflow command. And this part of the code is to connect to the previous Roboflow space that I have shown. Okay. Next, we confirm the location of the downloaded dataset within our Colab environment using the dataset.location command. And then the heart of our task is to train the YOLO V7 model. We use the train.py script with various parameters specifying device, batch size, number of epoch, image size, data configuration file, hyperparameters, YOLO V7 configuration file, pre-trained weight, and a name for the custom model. So in this case, we use up to 50 epoch. And since we can see 50 epoch completed in 0.381 hours and almost 20 plus minutes. And then after training, we can use the train model to detect object in an image. Here we use the detect.py script with the train weight, confidence threshold, image size, and the source image that we want to test. So as you can see, the image with the result is saved in runs detect exp3 helmet underscore jacket 07366. So similarly, we can apply the model to detect objects in a video. We use the same detect.py script, but we adjust the source to the video file. So let me show you the tested images first in this detect exp3 folder. So we can see the model are able to detect safety helmet and safety vest in these images. Next is for the video file. So the video file is saved in exp4. So this is the video named ICS underscore test underscore video dot mp4. So that's all from me uh, for the simulation of task 2. Thank you.